Okay, so let's have the volume of a solid of a revolution. So using cylindrical shell. So volume or a certain enclosed area, so revolve around a certain axis, so can be solved so using cylindrical shell. So for example, in this one, so we have the shaded region, okay, and then we're going to revolve it, okay, so around y-axis, and so let's say I'm going to use, okay, so I'm going to use a vertical strip, so to represent that certain area, and then it will be revolved around the y-axis. So the volume or the solid that will be formed there, so will be a cylindrical shell. Okay, so a cylindrical shell, so it's a hollow cylinder. Okay, so with a certain thickness. Okay, so with a certain thickness, and together with the surface area of the cylindrical shell, so we'll be able to get the volume. So in getting the volume of a cylindrical shell, so we are using the formula volume. And then since that will be a cylinder, so the surface area of a cylinder, so if we have a cylinder like this, so the surface area, so would be the circumference of the circular base. Okay, so the circumference there is equals to 2 pi r. And then, so it has a height, okay? So it has a height. So therefore, the surface area, okay, so surface area would be 2 pi r, then multiply it with h. So this is the surface area. However, so since we want to find the volume, so we need, okay, so to take note of these. Okay, so since this is a shell, so what would be the thickness of that shell? Okay, so that's getting the volume of a cylindrical shell. So that would be 2 pi r times h times the thickness. So usually the thickness is the differential, and then the height. So we're going to follow whether that would be y upper minus y lower, or x to the right minus x to the left. So what is new here is the radius. Okay. So for example, in this case, if I want to find the height, so this would be the height. Okay, so the height is the y upper minus y lower. So height is it's the length of the strip used. Okay, so it's the length of the strip used. So since this is revolved around the y-axis, that would be y upper minus y lower. If it is revolved around x-axis or a line, an x line, so that will be x to the right minus x to the left. Okay, so what is new here? Okay, so what is new here is the radius. Okay, so the radius is the distance. Okay, so the distance of the strip. Okay, the distance of the strip to the axis. Okay, of rotation. So this would be our radius. So our radius here. So since this is moving, okay, so this strip is moving. And its distance, okay, so its distance towards the axis of revolution would be unknown. Okay, so that makes it actually equal to x. Okay, so if it is along with the x-axis, so if we're going to revolve it around the x-axis, it will be along the y-axis. So therefore, the radius would be y. But again, it depends on whether or whatever would be the whatever will be the distance of the strip to the axis of rotation. Okay, so usually, if it is just the axis of rotation is just x, or the x-axis or the y-axis, so if it is the axis of rotation is y, so r is x. If the axis of rotation is x, r is y. But then, if we have an axis of rotation other than the x-axis or the y-axis, so we have to consider the distance. Okay, so we have to consider the distance. Remember, the x and y here is only in reference to the x or y axis. But if it is other than that, so we need to draw what would be the radius. Okay, so that's just it. And in this case, so this would be the dx. So to define, so this one would become the height, and this is the radius, and then we have the thickness there. So we just simply supply that one to our formula V is equals to 2 pi r h t. So we'll be able to find the volume. Okay, so using a cylindrical shell. So as you can see here, if I'm going to use a vertical strip, so it will form as a cylindrical shell. So remember, in a vertical strip, okay, or in cylindrical shell, the height is always the height of the strip. Okay, so the height is always the height of the strip. So that would be the cylindrical shell. So if, let's say, for example, that would be a horizontal strip. So with this given area, so let's say this is an enclosed area. Let's say I'm going to use a horizontal strip here. So for the horizontal strip, and then I'm going to revolve it around the y-axis, so it will not form as a cylindrical shell. Okay, so why? So it's because the length of the strip here. Okay, so if I'm going to revolve it around here, so it will form a ring. Okay, so we're in the length of the strip, so would correspond to the radius. Okay, the length of the strip will correspond to the radius, then that will be a ring. However, that could be a ring or it could be a disc. Okay, so as long as the length of the strip so will be a radius. Okay, if the length of strip is radius, then that will become a disc or a ring. However, if the length of the strip will correspond to the height, okay, so to the height, then that one becomes a cylindrical shell. Okay, so that's on how to differentiate the two. Okay, so if the length of the strip so will serve as the radius of the solid, then that could either be a disc or a ring. However, if the length of the strip so will correspond to the height of the formed solid, then make it a shell. Okay, so I can further let's try to show that further. So let's say we are given this example. So consider the region so bounded by the graph, so x equals to y squared. So it's a parabola. Then a line x equals to 4 and the x-axis or y is equals to 0. So find the volume formed by revolving this region about the x-axis. So using a vertical strip, and second one is using a horizontal strip. So I'll be inserting, so it's x, okay. Four squared. Okay, so I need to reduce it. So I have the y-axis and then we have the x-axis. And then, so the first one, so I can plot, okay, so x equals to 4, right away. So this is 1, 2, 3, 4, 5, 6. And y squared. 1, 2, 3, 4, 5, 6, 7, 8, 9. So x equals to 4. So this is 4. So this is the line corresponding to x is equals to 4. And the other one, we have the parabola. So y squared. So x equals to y squared. So this one is a parabola, so opening to the right. Okay, so when x is 0, okay, or when y is 0, okay, so x is 0. Then when x is 4, okay, so y is positive and negative. And x is 4, that would be positive and negative 2 for the y. Okay, so this is too small. Anyway, so when x is 1, so y is positive negative 1. Okay, so I don't need... So this is y is equals to, or sorry, x equals to y squared. Okay, so for the first one, so I'm going to use a vertical strip. The second is I'm going to use a horizontal strip. So I'm going to copy this. So for the second requirement. So for the first requirement, so since I'm going to use a vertical strip, so this would be a vertical strip. So this one becomes dx. Okay, so since this would be revolved around the x-axis or about the x-axis, okay, so what will be formed there? So will be, as I've mentioned, so this time, if I'm going to revolve it, so it will form a disc. Okay, so we're in the length of the strip, so will correspond to the radius, right? So this one, okay, so that is our radius. So our radius will be the length of the strip, so that is y upper minus y lower. So our y upper will be the parabola, but since we have x equals to y squared, so this is the same as y is equals to x raised to 1/2. Okay. So that would be our r. And then so we have our dx, okay, so which would be the height. And then, so using our formula, so our formula would be, so since this is a disc, that is pi r squared times the height. Okay, and then that is from A to B. So I'll have pi. Our r is y upper. So we're in y upper is x raised to 1/2. Then minus y lower. Y lower is the y-axis, wherein that is x is equals to, or that is y is equals to 0. So that makes it minus 0, then square it. And then the height, so corresponds to the thickness, okay, so of the disc. So that makes it dx. So since our differential is dx, So we are going to get our limits, okay, or boundaries along the x-axis. Okay, so the area covered by the parabola and the line x is equals to 4. So it starts from 0 until 4. Okay, so that makes this one 0 to 4. So volume then, so I can move out 4 or pi, then from 0 to 4, x raised to 1 half raised to 2, so that makes it x dx. Thus the volume would be pi, so integral of x is x squared all over 2, then evaluated from 0 to 4. So the volume then would be pi, so substitute, so 4 square all over 2, so minus, so 0 square all over 2, that is 0. So making it, so 4 squared is 16, so 60 divides 2 is 8. So I'll have 8 pi cubic units. So that would be the volume. So using a disk, okay, so this is a recollection of the last topic. So next, so what if we're going to use a horizontal strip, okay? So since the covered area is the area of the parabola and the line along the first quadrant, so this time, so I'm going to use a horizontal strip, okay? Since I'm going to use a horizontal strip here, so this one becomes the dy, and then, so what happens here is that the line, okay, so that will be, or the volume, the solid that will be formed there is actually a cylindrical shell. So because the strip this time is no longer the radius of the solid, but the strip corresponds to the height of the solid. So that's making it a cylindrical shell. Okay, so as long as the strip length will correspond to the height of the solid, then that makes it cylindrical shell. So if the strip will serve as a radius, then that is either a disk or a ring. So now, so how do we find the height? So this would be the height. So height is actually x to the right minus x to the left. Okay. So since we are revolving this one around the x-axis, so x to the right is the line x equals to 4, and then x to the left, so the left portion of the strip touches the parabola, so x to the left is equal to y squared. So how about the radius? So for the radius, so this would be the radius. So the radius is the distance of the strip to the axis of rotation. So since we do not know what is that, r is actually equal to y. Okay. So if it is its distance from the y-axis, then that would be x. Okay. But if the radius, the distance of the radius to that of the x-axis, so that will be y. So thus, we can now get the volume. So volume, so from A to B, our formula would be 2 pi RHT. So 2 pi then, our R is y, and our height is xr minus xl, x to the right, so which is x equals to 4, and then x to the left is y squared minus y squared. So that would be the height. Then the thickness, so that's the differential dy. So since this is dy, the limits that we will be using should be along the y-axis. So that is, it starts from 0 until 2. Okay, so that is for the enclosed area, from 0 to 2. Thus we have, so I'll move out 2 pi, so from 0 to 2, and then I'll distribute, so that is 4y minus y cubed dy. So 4y minus y cubed dy. So 2 pi then, 4y would be y squared all over 2. So 4 over 2 would be 2y squared. Then minus y to the fourth all over 4. Then from 0 to 2. So 2 pi then. So we substitute the upper boundary. So 2 times 2 square. So minus 2 raised to 4 over 4. And then, so 0 for 2y squared, and then y to the fourth is 0 as well. So the lower limit would just be 0. So v then would be 2 pi. I'll have 2 squared times 2, that will be 8. So 2 raised to 4, 2, 4, 8, 16. 16 divides 4 is 4. So 8 minus 4 is 4 times 2 pi. That would still be 8 pi cubic units. So as you can see here, so since the given solid or the volume of the given solid can either be resolved so using a vertical strip or a horizontal strip, the method may be different. Okay, so one using a cylindrical or a disc, the other one is using a cylindrical shell. But regardless, whatever would be the representation of the solid, so whether it is a shell or a disc, so we arrive to the same volume, okay? So which is 8 pi cubic units. Okay, so let's have another example. So for example number 2, so consider the region bounded by the graphs y is equals to x cubed, y is equals to 2 minus x, and y is equals to 0. So use shell method so to find the volume formed by revolving this region about the x-axis. Okay, so it's about the x-axis. Cube. So we'll graph it first. So this one is along. So I'll start with the line. So y is equals to 2 minus x. So I'll get the x-intercept. That is when, or to get the x-intercept, so we let y is equals to 0. So y is equals to 0, then we make 0 is equals to 2 minus x. So x will be equal to 2. So for the y-intercept, so we let x to be 0. So y then would be equal to 2 minus 0, so y is equals to 2. So x is 2 and 2. So 2 and 2. And okay. And then, so let's try to get the point of intersection. So y is equals to x cubed. Then the other one is y is equals to 2 minus x. So x cubed then is equals to 2 minus x. So x cubed 2 minus x. So x cubed plus x minus 2 will be equal to 0. Okay, so this is cubic. I can only guess. So that one of the roots. So we can use synthetic division. I'll have for x cubed will be 1, for x squared is 0, for x is 1, and then this is negative 2. Okay, and then so let's say one of the roots will be positive 1. So I'll have 1. 1 times 1 is 1. So 0 plus 1 is 1. So 1 times 1 is 1. So 1 plus 1 is 2. So 2 times 1 is 2. So this is 0. So that will be, one of the root is 1. So I'll have x minus 1 here. And then ito yung matitira. So x squared plus x plus 2. Okay. So since I'm assuming that the point of intersection is on the first quadrant, so I'll have here x equals to 1. Okay, there are still other 3 points or 2 points of intersection, but that's no longer my concern. So when x is 1, so I'm just going to substitute it. So it says that y is equals to 2 minus x. So therefore, y then will be equal to, so 2 minus 1, which is 1. So therefore, the point of intersection will be 1 and 1. So this is the x-intercept, this is the y-intercept, and then we have the point of intersection. So we're good to plot this one. Okay, so the x-intercept is 2. So let's say this is 1, 2. So 1, 2. Okay, so this is the line. Y is equals to 2 minus x. And then we have y is equals to x cubed. Okay, so from there, so when x is 0, so y will be 0. But then when x is 1, y will be 1 as well. When x is 2, that will be 8, 2, so on. So most probably, this is how it looks like. So that's what it has here. So that is y is equals to x cubed. But then, so our concern here would be, okay, so the area formed. Okay, so the area formed at the first quadrant this one is y is equals to x cubed. And then the other one is the y is equals to 0, or the x-axis. So this is the y is equals to 0. So now we're going to use a shell method. So to use a shell method, so I'll be using a horizontal strip. So I'll be using a horizontal strip, so which will be parallel to the axis of rotation. Okay, so that's another thing. So when the strip is parallel the axis of rotation, then that makes it a cylindrical shell. Okay, so just like this one, so this is horizontal. Actually, it's the same with the first example. Okay, hopefully, okay, it will be different for the last example. Okay, so look at that. As long as the strip is perpendicular to the axis of rotation, so then that makes it a cylindrical shell. So if it is parallel, okay, or if it is perpendicular, I mean, if it is parallel, okay, so if the strip is parallel to the axis of rotation, then that makes it a cylindrical shell. Okay, so let's take note of that. So when the strip is parallel, then that makes it a cylindrical shell. Then when the strip is perpendicular then that makes a disk or a ring. Is parallel to axis of rotation. So now, so this would be the cylindrical shell. So we'll define the height. So that will be the height. So the height is equals to, so that means that is x to the right minus x to the left. Okay, so since that is horizontal, so x to the right minus x to the left. Then while the radius, so this would be the radius. So the radius would be y distance from the axis of rotation. Okay, so this is y. So y distance from the axis of rotation. So then our volume, so we can now compute our volume so as 2 pi r h t. So from 0 or from A to B. So 2 pi, our r is xr minus xl. So our x to the right is the pink line. So which is, so since y is equals to 2x, so therefore x will be equal to 2 minus y. Okay. So this is the same as x is equals to 2 minus y. So r then is 2 minus y. Then our x to the left, okay, so we have y is equals to x cubed. So therefore, this is the same as y raised to 1/3 is equals to x. So that would be minus y raised to 1/3. Then our dt is the thickness, or thickness is dy. So since that is dy, so our concern there so would be the limits would be along the y-axis. So that is, so the area covered. So this is the area covered. So which ranges from 0 to 1. Okay. So that's the point of intersection, the 1 and 1. So 0 to 1. So for our limits. So in determining the limit, so you're just going to take a look at the area. Okay. So take a look at the area. If this dy, so it should be, so what's the maximum y? So in this case, the area can only reach until 1. Okay. So that starts from 0 until 1. So now, so we can get our volume. So by solving or I forgot. So I forgot the r. Okay, so I'll have 2 pi. R is y. Okay, so there should be y there. So 2 pi y. So times 2 minus y cubed. So volume then would be, so I'll move out 2 pi. Then from 0 to 1. Then y times 2. So 2y minus y squared minus y raised to 4/3 dy. So we get the volume. So 2y will be y squared all over 2. So 2 will be cancelled out. So minus y cubed over 3. So minus y raised to 7/3. And then this would be 3/7. And that is from 0 to 1. So V then will be equal to 2 pi. So substitute the upper limit. So I'll have 1 square. So minus 1 cube over 3. So minus 3 over 7. So y raised to 7 over 3. And then for the lower limit, so since everybody or all the terms involves y, so that would just be 0. So v then will be 2 pi, so 1 minus 1/3 minus 3 all over 7. So v then would be 2 pi, so LCD would be 7. This is 7, or sorry, LCD will be 21. So this is 21, so minus 7 minus 3, it's 9. So 16, 21 minus 16 is 5. So 5 times 2 is 10. So the answer would be, so 10 over 21 pi cubic units. So that will be the volume. So 10 all over 21 pi cubic units. Okay, so let's have our last example. So considering the region bounded by the graphs, so y is equals to x squared and y is equals to 8 squared of x. So use the shell method so to find the volume formed by revolving this region about line x is equals to 6. Okay, so this time, so our axis of rotation is vertical, so x is equals to 6. So what will be the bounded area? So let's graph it. Okay. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. So we have a parabola, then we have a curve 8 square root of x. So for the parabola, but okay, so let's try to get first the point of intersection. So we are given y is equals to x squared and y is equals to 8 square root of x. So we'll equate that. So x squared will be 8 square root of x. So we want to remove the square root, so we square both sides, so that makes it x to the 4th. And then 8, or sorry, so that will be 64 x. So we transpose that. So minus 64x goes to 0. So we factor out x. So that makes x cubed minus 64 is equals to 0. So thus, our x sub 1 will be 0. The other one is x sub 2. So x cubed minus 64. So that would make it equals to 64. So therefore, our x will be 4. Okay. So using y is equals to x squared, so when x1 is 0, so therefore y1 is 0. Then when our x is 4, so y2 is 16. So therefore our point of intersection, the first point of intersection is 0, 0. And then the second point of intersection will be 4 and 16. So 4 and 16. So those are the points of intersection, 0, 0. So the other one is 4 and 16. This is 4 and 16. So now, so for the parabola, so I'll start with y is equals to x squared. Okay, so when y is, or when x is 1, so y is 1. When x is 2, y is 4. When x is 3, y is 9. And then it's 16. So this would be our parabola then. So this is y is equals to x squared. So the other one, we have 8 square root of x. So y is equals to 8 square root of x. So when y, or when x is 0, so y is 0. But then, so when x is 1, so square root of 1 is 1 times 8, it's 8. So this is 8. Then when x is 2, so square root of 2 times 8, I think that's around 11 point something. And the other one is when x is 3, so square root of 3 times 8, so that's 13 something. So that's why if you're going to plot it or draw it, so that's how it looks like. So this is y is equals to 8 square root of x. So now, so we're going to revolve it around the x equals to 6. So this is the x equals to 6 axis. So we're going to revolve that around there. So I'm going to mirror it out. So most probably it looks like this for the mirror. And thus, if I'm going to use a vertical strip, so this will be dx. So what happens now? So as you can see here, so it is again parallel. Okay, so it is parallel to the axis of rotation. So if it is parallel to the axis of rotation, so take note of this. So it is a cylindrical shell. So this is the strip. The strip is parallel to the axis of rotation. So thus, it forms a cylindrical shell. So what will be the height? So this is our height. So height is y upper minus y lower. So our y upper is the red one, 8 square root of x. Y lower is the pink one. So y is equals to x squared. But then, so how about our radius? So this is our radius. But then, so what we have is the distance, okay? So the distance of the strip, this one. So the distance of the strip to the y-axis, so similar before. So in this case, the distance of the strip, so since this is along the x-axis, so the distance of the strip to the x-axis is y. But in this case, the distance of the strip to the y-axis, so this is actually equal to x. So this is x, and then this is the radius. But what is this distance? So the distance of the axis of rotation, so to y, is actually 6 because x is equals to 6. So therefore, this is 6. So if the whole length of the axis of rotation, so to that of the y-axis is 6, and then the strip to y-axis is x, so therefore the r then will be equivalent to 6 minus x. So for the radius. Okay, so this is what makes it different if we rotate the enclosed area, so to align other than the x-axis or the y-axis. Okay, so we have to subtract. Because remember, the x and the y distance is always in reference to the x and y axis. Okay, so now that we have all of that, so I'm going to use our formula. So from A to B, that is 2 pi r h t. So 2 pi, our r is 6 minus x. And then our height is y upper, so which is 8 square root of x, or 8x raised to 1 half. And then minus x squared, so 4y lower. Then our thickness is dx. Since that is dx, so we are concerned, okay, of the limits. Okay, so for the area, so our limits would be the enclosed area. Okay, that is from this one. So this is our upper limit, and this is our lower limit. So lower limit is 0, upper limit will be 4. So 0 to 4. So our volume then would be 2 pi. So from 0 to 4, then we distribute. So using FOIL method. So 6 times 8 is 48x raised to 1 half. Then outer. So 6 times negative x squared. So negative 6x squared. So inner will be negative 8x. So 1 plus 1 half is 3 over 2. And then last term, so that will be negative x and negative x squared. So negative x cubed dx. So now we can integrate. So 2 pi. So 48. So multiplied it with x raised to 1 half plus 1. That is 3 over 2. So times 2/3. So minus 6x cubed over 3 minus 8 times x raised to 3 plus 2 is 5 over 2. And this would be 2/5. And minus x to the 4th over 4. So from 0 to 4. So v then would be 2 pi. So 48 divides 3. So that is 116. So 16 times 2, it's 32. So x raised to 3 over 2. Minus 6 over 3 is 2. So x cubed. Minus 16 all over 5. X raised to 5 over 2. Then minus x raised to 4 over 4. From 0 to 4. Then we substitute the upper boundary. So that is 32 times 4 raised to 3 over 2 minus 2 times 4 raised to 3 minus 16 over 5 times 4 raised to 5 over 2. So minus 4 raised to 4 over 4. And then since all of the terms involve x, so we substitute 0. So the lower boundary will all be 0. So that's 2 pi. So 4 raised to 3 over 2. So that would mean the square root of 4 raised to 3. So square root of 4 is 2. So 2 raised to 3 is 8. 8 times 32, 64, 1, 2, 8, 256. Okay, so it's 256 minus 4 raised to 3 is 64 times 2 is negative 128 minus 4 2 raised to 5, it's 2 4 8 16 32. So 32 times 16 will be correct. 512. Okay, so 512 all over 5. Then 4 raised to 4 over 4, it's 4 raised to 3. So that makes it 64. And that should be, okay, sorry, this should be plus. So plus 64. So 256 minus 128 minus 512 over 5 and plus 64. That makes it 448 over 5. And multiply it by 2. So making it 896 over 5 pi cubic units. And that is the volume of the cylindrical shell or the solid using cylindrical shell. Okay, so just to wrap it up, so again, what's the difference of the cylindrical shell with this and the ring? So just take note, where is the strip parallel? If the strip is parallel along the axis of rotation, that makes it cylindrical shell. So that means the strip, so will have, or the length of the strip, so will correspond to the height. But then if it is, if the strip is perpendicular, okay, so if it is perpendicular to the axis of rotation, so that makes the length of the strip equal to the radius. So thus, that would become either a cylindrical or a shell or a ring or a disc. And then for cylindrical shell, so take note of the radius. Okay, so the distance, okay, so the distance of the strip to the x or y axis could either be a y or an x. Okay, so we have to properly draw it so as to really see, okay, so how we can represent that r. So that's the only tricky thing, okay. But then if it just revolves around the x-axis or y-axis, so it's just simple. It's just either an x or a y. And that will be all for the volume.